Everybody. Sorry, a little bit sick today, but today we're going to work on some circles, get some circle stuff done. Ooh, my pen is not working too well today, but I know we've got a quiz coming up. Today's virtual day. Thought I'd just film this video for you guys quick. Let's get started. Today we've got parts of a circle, power theorems, angles and stuff, plus those few extra theorems, circumference and lengths of arcs, which means pi. Look at that. Look at that beautiful pi. Oh, wow, this is going to be rough with the pen. And then the walk around problem, which is also just a little extra thing. Hopefully there's not too many of those in the test. Those are long and complicated. Anyway, it's not too many. Yeah, you guys will be fine. I don't want to be like, I don't know, kindergarten teacher over here, but what is a circle? What is a circle when you think about it? Well, you've got your center of the circle, and basically, here's your radius. It's just the path of this point on the end of the radius. So if you spun this around, like imagine you tied a rope to a post. Here's your post, here's your rope, and then you spun it around like that. I don't know what's up with my pen, but it's kind of cool looking. Anyway, if this is like a top-down view. This is your post, this is the rope, and then this is the path that the rope takes. So because of that, why are all radii congruent? Well, it's all the same rope. Like, you're never going to get a longer piece of it because the rope doesn't get any longer or shorter. And why is it 360 degrees instead of like 100? I don't know the historical answer to this, but if you think about like divisions of 100, if you wanted to take half of 100, you can get 50. Wow, this is really bad. Quarter of 100 is 25, but then beyond that, it's just kind of like, I think like an eighth is 12.5. 12.5, and then after that, it just kind of gets into weird other numbers. So think of 360. You can get quarter, well, let's see, half, quarter, eighth, a third, a sixth. All of those are even divisions. So, like with your 90, 180, 270, and 360, those are all quarters of a circle. So whenever someone says 90, you can know it's like 1/4. 180 would be the whole semicircle. 270 would be like 3/4 of a circle, and then 360 is the entire circle. There are a couple terms that we need to know with this. So diameter, radius, chord, tangent, and secant. I'll try to draw these out. Hopefully my pen doesn't dislike that though. And I always think it's fun to explain the etymology of these. It makes it a little easier to understand if you ask me. So I'll give you with diameter. Dia meaning like a cross, and meter meaning measurement, like a meter as in the length in metric system is a measurement. That's what that root word means. So you're just measuring across. That's what a diameter is. Radius, think of like if you're a little kid drawing a sun with rays like this, but imagine your sun is just the little point in here. So the radius will be the rays that come off of this. Radius. Next up is a chord. Think of like a guitar. Guitars have chords over there. Like, here, I'll draw them bigger. This is like their hole in the guitar. It's the rest of the guitar. Sorry, guitars aren't really circular, but that's what you can think of there when it just goes from one side to the other. And then tangent. If someone's talking, mostly like me, because I like to do this too sometimes, is you'll be talking, and you're going around in your conversational circle, and then you're like, oh, I want to keep talking about this. So that's a tangent. A tangent is just like a line that goes from a point on the circle out, or from a point out here onto the circle, either way. But it's like you're just going round, and you keep going off of it. And secant means to cut. I think that's just a good way to think about it. Like you're coming in, you're cutting it. You're cutting it into several parts. It's not a diameter per se. Like it's not going to be straight in half. I mean, it could be in half, but it's not necessarily. It just means you're going to cut it into two parts. Next, we'll talk about the power theorems. The important thing to remember about this is these are only for lengths. You can't use these to find angles, even if there are other angles in the problem. It just means you're not using them for angles. I think the important thing with this, and really a lot of things, is either you got to memorize them, you got to know what you're doing, or you got to understand why they work. So I'll give you a little bit of both. So chord. Here's your chord. Here's your other chord. We'll call this chord A, chord B. So you take this one times this one. So like the one half of, or sorry, I started with B. The one half of chord A times the other half of chord A, and then equals the one half chord B and the other half chord B. Sorry, that was really bad talking. Words are hard, but basically you multiply the halves by each other, and then you get your lengths in there. So if you need to put an x in there, you can find your x. Secant, secant. Let me clear this off. Secant, secant is, remember, you're cutting it. So secant, secant. You do like this whole thing. Like this is A. This is B. You take the whole A times this little part here. This is the exterior, where it is on the outside of the circle. Exterior meaning outside. So the whole A times the little, but ext. And then that is equal to, sorry, this is a vertical equal sign, but same difference. B times the tiny exterior. And then lastly, you got the tangent secant. Tangent, like you're going off on a tangent. You start here, and you just go like that. And then you got your secant, which is cutting. For this one, the tangent will just be itself squared. So this is the tangent, secant. Tangent is just itself squared. And then the secant is the same as this secant, secant one. So the secant is the whole thing times the little thing. So B times exterior. And so that's how, if you want to memorize the formulas, that's how you'd memorize those formulas. But if you want to understand it, chords, like, they don't need anything else. They're inside the circle. They're pretty tame. They're fine with just multiplying themselves with each other. But secants, they want to kind of cheat it, you know? They want to be a little bigger. So the secant here is like, instead of multiplying just this times this, I'm going to take the whole thing and then multiply it by this. You know what I mean? They take the whole thing and then the little part. So it's going to end up being a little bit bigger of a number. And then tangents, they're kind of going out here. They don't have another like half or something to multiply by. So tangents, because they're all by themselves, just have to multiply by themselves. I think, is that all I have for that? Yeah, that's all I have for that. So angles and stuff, this is like all the inside, outside, center, whatever, angles. Again, you got to memorize it or you got to understand it. Formulas that you would memorize if you want to just memorize them is the central angle. So anything where it goes through this point here, that's a central angle. This angle is the same as this arc. Same number of degrees. You can just completely copy down the answer there. When it's on the circle, this is also called an inscribed angle, like that. So it can be a chord or a secant, which is chord, secant, no, sorry, can't really see my pen. Then that's just half of it. So this arc is half of this arc, 1/2, or the other way around, this one is 2 times. It's inside the circle, but not like in the center. So if it's like this, then you're basically doing an average. You add the arcs, you add these arcs together and then divide by 2. If it's on the outside of the circle, so this would be like your secants or tangents, and you do it like that. You do the big arc minus the little arc divided by 2. So it's like a reverse average type of thing. So that's all the memorization you need to get, but I would think about it like center angle, easy. If it's on the circle, I would say think of it like a beam of light. So this is your light source. This is your, I don't know, put like a little light bulb or something. The start of the light bulb will be really small, but then by the time it hits the outside of the circle, it'll be really big. It'll be twice as big. So that's how I would think of it, like that. In circle, again, like just like the chord power theorem, they're kind of nice and tame. They don't really care about beating each other, so they're sharing. So they take the average and then share the average. It's like circle communism, I guess you could say. I don't know. Maybe that's just me. So you take the average of that one. If it's outside, then this big arc is jealous, and this big arc wants to eat the little arc. But then if that big arc eats the little arc, it's going to be really big. It's going to be too big, so you got to cut it in half. I think that's just... That one might be a little bit of a stretch, but hopefully that makes sense to you. When it's outside and there's a much larger arc, the big arc eats the little arc, and that is the subtraction here, I should say, and then divides by 2 because it's already too big. And then here I'm just going to go quick fire. I'm already going pretty fast, but here's the quick fire extra theorems. I wouldn't, don't worry about it if you forget these because they only show up a couple times. Like if you don't know any of these, it's probably a problem, but if you forget one, you're just going to get 1 point off. That's kind of where I'm going with this. So some of them are just pretty easy. Let me just go through these quick. So radius goes to the center, perpendicular to a chord. Here's your chord. It also bisects it. So perpendicular, sorry, I'm trying to draw perpendicular. So these are 90-degree angles, and these are also congruent. Next, if two tangents start at the same point, they're congruent. So here's the same point. Here's a tangent. Here's a tangent. These are congruent. Sorry, that's more of a secant. It should be like out here. If two chords are congruent, the arcs they form are congruent. So if you say take these are congruent, then these will be congruent. If two inscribed angles intercept the same arc, the angles are congruent. Let me look at the, got some papers here. Let me look at the example for this. I kind of forget how this works. Take that and that, like that, yeah. So see, this whole thing here is intercepting this arc, and this whole thing here is intercepting this arc. It's kind of like transitive property, because they're both looking at the same thing. These are going to be the same angles. So this angle and this angle are congruent. And any angle that's inscribed in the semicircle is a right angle. That's just a fact of it. So semicircle means it's going exactly in half. If it's inscribed, then it's gonna have to be a right angle. And then is this the last one? I need to see if it's the last one. No, there's a couple more. Tangent and tangent angles are supplementary to the little arcs. Technically, they're minor arcs, but here's your two tangents. This angle here, let's say it was like 45. Then this little arc here would be 135 because it's supplementary. That's a good one to know. Sorry, my pen's really bad today. And then opposite angles of an inscribed quadrilateral are supplementary. It's kind of a lot of vocabulary words here, but quadrilateral means four sides. So you connect the four sides. The opposite angles are supplementary. So this angle and this angle add to 180. Sorry, wow, this is really bad. As well as this angle and this angle. So just remember that they're opposite from each other. And I think that is all. Is that all? Yeah, it's all of them. So those were, let me go back. These are, here's your whole list if you want to like take a screenshot of anything. This would probably be what you want to take a screenshot of. But again, don't worry too much if you forget some of these. And then circumference and stuff. This is the part where some people get a little confused, so I'm going to go through the notes of this first before I do a problem. You've seen pi before, hopefully in like 7th grade, at least in my school system, you learn about pi. And then you're never going to stop seeing it. If you take Algebra 2 trig, or calculus, or any higher level math, you're just not going to ever get rid of it. And I think it's kind of scary because it's like a Greek letter, and you know, it means a lot of numbers, stuff like that. Just try not to do anything with it if you can, if at all possible. So like, if you had root 2, how you just leave it like that, or if you had x, you just leave it like that. You don't have to say this is like 1.14 or whatever, and then like, or x, you don't have to convert it to whatever it actually means. So when you see a pi, for the most part, just avoid putting it in as a real number unless they ask you to fully calculate it out. And here's the most important thing that you need to remember about this is the whole circumference equals pi times diameter. That finds your circumference, or your diameter for that matter, like no matter which one you have, and then every problem will end up having that. So again, I think Mr. Colander said this, if you're stuck, if you don't know what to do in one of these circle problems, you probably should start with this formula and see what you can get out of it. The other thing I was just going to mention quick is, I think it's a little confusing that when you think of a circle being 360 degrees, it's not like 360 long. Like, it's not the same as saying this circle is 360 feet. It's just like a fraction of the circle. Sorry, this is bad 360. So for this example, like if I said, what would this be? This would mean that the diameter is 48. So diameter equals, or circumference equals pi times diameter. So here's your circumference. It's still 360 degrees because 360 degrees is the same as a fraction. So 360 is like saying 1 over 1. So 48 pi would equal your circumference of 360. And then after that, when you get like a 90 degree angle, you know that 90 degrees is 1/4 of 360. And if you don't know that, you can use a calculator. You could say like, how do you do this again? I forget. 360 times 1/4, you get 90, or I think, is it like, yeah, it'd be 90 over 360 would also be 1/4. So if you ever need to find what the ratio is, you can do that. But once you know that, you know that's a quarter of the circle. And so if you know that the whole circle is 48 pi, then you can divide 48 pi by 4 and get 12 pi. So the ones that have pi in them are the actual length. Like, this is actually how long it is. If it's degrees, that means it's just like a fraction of it. Oh, that was it. Yeah, I guess the only other thing I was gonna say about this is if you have like a semicircle in the problem, like sometimes you get the problems where like this is a square and you have to find the area of this, or not the area, the perimeter of this. What you can do is you can either say this is 30. You can either take the 30 and then do the c equals pi d. So the diameter is 30, so the circumference is 30 pi. Or you can just think of it, since it's a half circle, if you don't even want to find this, you just have the radius, you can say the radius is 15, and because it's a half circle, it'll be 15 pi will be your circumference of the half circle. But in any case, don't think about it too hard. Like, any way that it'll help you, just take whatever steps you need. And then the last thing is the walk around problem. This one is kind of its own thing. Like, you could use the other formulas for it, but it's kind of something you have to learn on its own. Don't let it scare you. You know, it's not actually a ton of math. It's just kind of like a lot of numbers, I guess I could say. So you start by labeling your sides. So we know that AB is 9, CD is 18, BC is 12. Sorry. And then this is your side that you don't know. The corners are going to be congruent because of tangent-tangent theorem. So remember, if you have two tangents, these lines are going to be the same. So you just start going. So this whole side is 9, and this one is x. So this part here has to be 9 minus x. And then since it's the same over here, you can say this part is 9 minus x. Same with this. So this is 12 minus x. And this is also 12 minus x. And then this last side here is where it gets tricky. The whole thing is 18, and this part is 12 minus x. So, I mean, actually, it's 18, which is the whole thing, minus 12 minus x is that side, and this side. So now you have this thing, this like whole side together. So you know the whole formula is going to be 9 minus x plus 18 minus 12 minus x. And also just don't forget your parentheses, because that's important here, and you'll see why in a second. The x will always cancel out, because when you distribute this negative into the parentheses, you're going to get a negative 12 plus x, and your other x is over here, so you're canceling both these x's, and then it just becomes like a addition problem. So you got 9 plus 18 minus 12, and check it out. This is 6, so 9 plus 6. These are 6, and then this would be 15. So there's your final answer, 15. Is that all I had for this slide? Yeah, it is. Yeah, that's basically it. I think there's something else I was going to say about this, and that would be just to, like, don't lose track of where you're going with it, I suppose. I don't really remember what I was exactly going to say, but you start over where your x's are, and you're just trying to make your way over here, and that's why you're walking around. You're walking around filling in all these different points, but don't get disheartened, I guess I should say. And then, with that, that's the end of it. Went through everything pretty much as fast as I could, because, you know, it's a lot of content to cover. Practice. You know, we got a whole bunch of review sheets, or you can ask ChatGPT, or you can ask me for some extra problems. I think just in general with math, the best way you can learn anything is to keep practicing it. And then when you get to the test, don't just like freak out because you don't know how to do something right away. You just gotta like use your brain to get the best guess that you can make. Or skip it and come back later, which is the generic test advice I think everyone should hear. If you can't figure it out right away, come back to it later and maybe you'll have a better idea. And there you go. That was my whole presentation. Try to keep it under 20 minutes. Thank you for watching. Good luck on your test, everybody.